Hi everyone, my name is Ankit Kumar Singh. I am currently pursuing my Bachelor of Technology in Electronics and Communication Engineering from IIT IS in Hindenburg. During my JEE preparations, I always used to like the physics most. So, for this demo video, I opted the topic SHM, Simple Harmonic Motion, which I consider as one of the most fundamental subjects or topics for the further chapters like wave motion and optics. Now I will start this topic SHM, that is simple harmonic motion. Before starting this topic, I would like to mention few terms which I believe that they are important and you will come across these topics when you will read the subject through your study material. The first term is periodic motion. So, as you all know that motion represents movement of any particle. It can be any linear motion or circular motion. And if we will classify the motion in terms of um, time, so in that case, motion is classified into two types: a periodic motion and another one is aperiodic motion. So when a motion is repeated continuously after a specific period of time, then it is termed as a periodic motion. Just now I have said that motion is repeated continuously after a specific period. So this specific period is called time period. Okay. Now the another term is frequency. So frequency is classified as number of number of oscillations or the number of events or motions which has taken place in 1 second. So by using Gaussian proportion, we can calculate frequency that will be equal to 1 by Ts. The another term that we will generally come across is oscillation. So oscillation is a specific kind of periodic motion in which particle moves to and fro about a fixed point called mean position of oscillation. I will like to explain this topic using a few diagrams. Assume that a particle is there. Assume that this is a particle. This is a particle which I have made this one. I will choose another color. This is a particle. This red dotted particle. So this particle is moving on this line to and fro. It is going here. Again, it is returning from here to here. Again, it is going back to its original position. So I will introduce few of the terms. This point is called mean position. I will just write mean here. This point is called extreme position. I have just written the subscript like ext. So if the particle is there and it is moving in such a way, it is moving to and fro about the fixed point, this fixed point or the central point. This point is called the mean point. So any motion, it is a periodic motion because it is repeating its task continuously after a specific time, and even it is moving to and fro about the fixed point. So it is called an oscillatory motion. So an oscillatory motion can be classified into three categories depending on the conservation of energies or how the energy is going to be utilized. They are classified into three categories. The first one is free oscillation. Any of generally a casual example is described for it, that the pendulum movement of pendulum is a free oscillation. It is happening in a environment where there is not any friction forces. The second one is a damp oscillation. Oscillation taking place in a resistive medium or resistive surrounding. The resistive forces acting on the particle, it can be of any friction forces on an air resistive forces. Now the third term is called force oscillations. term force oscillation, it is actually a damped oscillation which behaves like free oscillation due to continuous supply of energy. Whenever the energy of a particle is lost due to the resistive forces, so an equivalent amount of energy is given to the particle. Generally, that energy is given at the mean position. I can explain this topic why it is given at mean position in my next lecture. So it is given at the mean position such that all the lost energy is again regained and the particle can complete the same task again and again. Now, uh, we have to again see that particle movement. So I have shown the particle movement diagram here. Now, oscillations. Another example through which we can represent oscillation is using the energy diagrams. So see, I am drawing the energy diagram, potential energy diagram. One more thing, at the extreme positions, the potential energy is high, and at the mean position, the kinetic energy is high. And we generally assume that our system is in a free oscillation environment. So the total energy that is equal to the potential energy plus kinetic energy, it will be constant. So total energy is constant, potential energy plus kinetic energy. Now I will try to explain this topic using energy representation. So this is the mean position. I am representing it with M, and this is the extreme position E, and this is the another extreme position E. So the particle is located here. So see that this is a graph of potential energy, which is represented by the symbol U, and this is the location X. Just erase this down. This is X. Now the particle is there at mean position. It is undergoing oscillation about this point. So when the particle moves from mean position to extreme position, so in the energy diagram we can see that when the particle is moving from mean position to the extreme position, at this point its potential energy is increased, and every system tries to always be at a potential where its potential energy is the minimum. So a force will get developed in this situation, and this force which is getting developed, which will try to bring back the particle to its mean position or the point at its minimum potential energy. That point is that force is called a restoring force. So a restoring force will act opposite to its direction. A restoring force will act opposite, and if the particle is if it is moved in another direction, so again a restoring force will act in the same direction, in the opposite direction, sorry. So I have shown here that if the particle is moved from the mean position, its potential energy has increased, and if potential energy has increased, particle will try to reduce its potential energy, and to achieve that a restoring force is developed which will try to bring back the particle at its mean position. Now I will explain the next topic, SHM, which is the main core concept that we have to read in this chapter. So SHM, as the name suggests, it's simple harmonic motion. So something simpler things will be going to take place here. So it is a special type of oscillation in which the acceleration of particle is directly proportional to distance of the particle from its mean position. Okay, means it is an oscillation. It is an oscillation only, but a special type of oscillation where the force acting on a particle is proportional to its distance from the mean position. Generally, to favor the oscillation as SHM, its oscillation amplitude should be low. Okay, so to make any oscillation as an SHM, if its amplitude will be low, then that oscillation can be converted into SHM. Okay, after reading this point, we can say that okay, yeah, this can happen, but how it will happen? So actually, that acceleration acting on a particle will be equal to represented minus c naught x plus c1 x square plus c2 x cube plus something, any constant into x ki power n, c n x ki power n. But if the oscillation, the amplitude, if that amplitude is small, so the square, cube or higher power of the amplitude, the smaller value, will become further small, so they can be neglected. So in that case, the net force or the net acceleration acting on the particle will be proportional to x. So due to this reason, the small amplitude of the oscillation makes any oscillation as SHM.